Well, thank you, Victor, for that introduction. Thank you to Wendy and to Eric for pulling us all together here and for their support of ocean research and innovation. I have to say, I don't think I have ever seen such an esteemed gathering of luminaries in ocean research in my entire career, and my career has been a very, very long one at this point. And so this morning what I would like to do is talk not only about what challenge Schmidt has before it as an organization in terms of how it might best further advance ocean research with the substantial resources that it can bring to bear, but also challenge all of you as leaders of the ocean research community at a time that I think is a critical juncture for all of us as a community. So in my remarks, I'm going to be going back and forth between what I view as opportunities for Schmidt, but also opportunities for all of us within the historical context of oceanography. So as I note here, we are but 9 years away from the sesquicentennial of the HMS Challenger. And so the question I'm asking is, what will we look like 9 years from now? Now, you all remember the HMS Challenger. It left Portsmouth, England, for what is widely regarded as the first scientific voyage of ocean discovery. And it really set the stage for what has been the pattern for ocean research and discovery since. It was an interdisciplinary party that measured, sampled, and collected everything that was possible to do at that day and age. Now, one thing that I think is important that was not a pattern for later oceanographic expeditions is that its expedition leader, Sir Charles Wyville Thomson, died of exhaustion during its around-the-year voyage. And that left Sir John Murray to publish the results of the expedition, which were published in 50 volumes of the Royal Society, which drove research for the next 75 years. Now, the legacy of Challenger is that it defined oceanography as a very interdisciplinary field. Biologists, physical oceanographers, chemists, geologists, all working together. That when a ship goes out to sea, it should measure and sample everything that was possible. For example, Doc Ewing demanded that the Le Mans ships should stop at noon every day and take a core, no matter where they were, no matter what they were doing. That core repository was therefore at the ready when decades later, scientists figured out that stable isotopes could be used to decipher ice volume, and that led to the birth of paleooceanography and understanding climate cycles in the past, and that led to, of course, the Milankovitch hypothesis and understanding ice ages. Scripps, as an institution, insisted that whenever ships were underway, they would tow their magnetometers as part of their underway gear. That led to a vast repository of underway data that mapped the magnetic lineations in all the world's oceans and allowed the ability to put together the maps of plate tectonics and understanding how the plates fit together in time and space. Question we can ask ourselves is, what should ships be doing today in terms of that sort of sampling that can only be done from ships that will either today or sometime in the future blow open some new field of understanding that we might not even be able to predict today. And of course, another legacy of the Challenger is to carefully document and publish those observations for posterity. In fact, the results of the Challenger are available online today. But beyond the just basic needs for pure science, as Wendy already laid out to you today, we have pressing knowledge needs that go beyond just basic science. We have more immediate needs for policymakers that have to do with our quality of life and the survival of, it's basically about us. Are we going to have a world that is worth leaving to our grandchildren and our great-grandchildren? Questions such as, what is our climate future? Can we sustainably feed the planet from the ocean? How do we protect coastal populations at risk from ocean hazards? Are there new resources such as drug therapies, energy and minerals that we can harvest from the ocean? And can we do it responsibly? For example, back in the days of the Challenger, many ships actually harvested ocean energy for their propulsion. Now most ships fight the ocean's energy in order to propel themselves through the ocean. And can we improve ocean health in the face of a growing human population that actually pollutes the ocean? Now, let's consider the changing face of ocean science and contrast what science has been like in the not-so-distant past with what it is like now. First of all, decades ago, science was all based on personal contacts. Science was a pretty small society, and it was all about who you knew. Now, science is a pretty big enterprise. Your reputation precedes you. And for that reason, it's all about science integrity. If you do anything to destroy your reputation, you will probably never rebuild it. So it's all about reputations. Then, science was pure discovery. Today, it's all about the credibility of your finds. It doesn't do you any good to discover something if you can't convince others about the credibility of those finds. So it's all about documenting and convincing others that what you found is verifiable. In the past, there was such a thing actually as scientific consensus. Scientists could actually agree on things. Today, divergent views is actually abundant. It's rare that we have scientific consensus. In the past, people thought actually about science as building on a stream of facts that built on top of each other. Now we think more about science as evolving understanding along with uncertainty. And we never publish just, this is what a number is. It's never a number. It's always maybe a range of what we think something is along with uncertainties. In the past, scientists lived in ivory towers. Now we think of citizen scientists. And the rage is to engage the public in the process of discovery, to make them feel like they are part of the process of science. In the past, most science, even the Challenger expedition, was publicly funded. We're going now to the point where some science is even crowdsourced. In the past, we think of science as being hubristic, and now it is becoming far more humble. And basically, the change is that science is becoming more open, more diverse, more public, and in many ways more humble. So Wendy asked, what is the good news? I think a lot of this is actually good news, but there's also some bad news. And so one of the bad news things that I wanted to put up here, and I think a lot of you already know about it, is up until pretty much right now, education has been part of the science agency missions. It's been funded as part of NOAA's mission. It's been funded as part of NASA's mission. It's been funded as part of the DoD mission. And now that's all under threat, that education is being defunded from the science agency missions. And I think we have to really worry about that. Because how are we going to continue to engage the public that they should care about the oceans, that they should understand science, if science is not going to be part of our science agency missions? That's going to be a challenge that we're going to have to worry about. Okay, so now what do I think the goal for us as a community needs to be? I think we should help people understand the oceans so that they can make better decisions, either individually, publicly, globally, by giving them access to reliable ocean information in as close to near real time as possible, and make them part of the discovery and validation process. So they aren't just being told what to think and what to do, so that they feel that they can find out for themselves. Because, as you know, the public, they don't like to be told what to think. They like to be able to feel like they can find it out for themselves. So how are we going to achieve that goal? All right, so I'm going to take you through my view of ideally how we might do that. So let's imagine a world in which we lower the cost of environmental sampling dramatically. Now, this is already being done in other environments, and we're only tippy-toeing into it in the ocean environment. So, for example, in the space environment, Planet Labs is a young company based in San Francisco that is dramatically lowering the cost of space-based acquisition of Earth sensing, of environmental sensing. And you can see in the upper right-hand corner, that device is about the size of a bread box. And it does environmental observing, and it replaces sensors that would cost of the order of hundreds of millions of dollars, and it costs tens of thousands of dollars. And it goes up as a ride-along on a rocket. And it uses basically cell phone technology. And if it gets hit by some space debris or something like that, they throw up another $10,000 device. So radically lowering the cost of acquiring environmental sensing from space. Okay, unmanned aerial vehicles. These are decommissioned Predator-type drones from the military that are now being used for observing active volcanoes, for hazards such as fires, for looking at whooping crane and monitoring the number of young they're having in an unobtrusive way, lowering the cost of ecological monitoring dramatically, and putting vets to work at the same time. One of my own favorites is Nature's Notebook up there, which uses a cell phone and engages citizens in climate change science. Basically, by downloading Nature's Notebook to your cell phone, you turn every member of the public into a climate change network, where people can go out in their backyard and take a cell phone picture of the first robin to show up in their backyard, or the first bud to show up in their tree in their backyard. And because cell phone pictures are geolocated and time-stamped with a date, that information then goes into a database, and that can be phenology information that shows when spring is arriving sooner or fall is arriving later, you know, the trees turning color or animals going into hibernation. And when I was director of the USGS, my fantasy was being hauled in front of some congressional committee and having a climate denier challenge me on whether scientists were cooking the books on whether climate change was real. And I could put up a little plot of phenology information that showed citizen scientist data of average people all over the world taking information on when trees were budding or when trees were turning their leaves all over the world and saying, well, Congressman, here's the data from your own congressional district. These are your constituents showing how spring is coming sooner and how fall is coming later. And by the way, all the dots in purple are from your mother's cell phone. So are scientists cooking the books? I don't think so. So now, in the oceans, we don't have as much. I did show Open ROV down here, and I have to say I put this picture in before I even knew the Open ROV team was going to be here, so I'm not pandering to any group. But this device is but $200, and it's a great way for citizen scientists to get involved in sampling at low cost. Now, there's no point in having low-cost platforms that do environmental sampling if you can't put instruments on them. So the next step, after you have low-cost platforms to access the environment, is we need instruments. And the ideal with instruments is that instruments have to be interoperable. And so now imagine a world where all instruments are interoperable. They're interchangeable with power and communication systems, such that you can put an instrument on an AUV or an ROV or on a ship or on an unmanned aerial vehicle or on a surface solar-powered boat or on a mooring or on an ocean observatory, and it doesn't have to be re-engineered every time it gets put on a new platform. In the same way that my wireless device, if it's connected to the network, it's happy. If it's not connected to the network, I can work offline. It works on battery, or I can plug it into the wall. It's not going to suddenly be inoperable depending on its power situation. It can be hooked to the Ethernet, or it can be in a wireless situation. It's happy no matter what its connectivity situation is. Systems, switch from battery to AC to DC, and instruments automatically discover their connectivity situation. So instruments that are interoperable and move from platform to platform. That would be the ideal way to set up our instruments. Okay, now imagine, best of all, data interoperability. Now, I know the MMI guys are here, but I made this slide before I knew you guys were here. So again, this was already here. Data interoperability is probably the most important thing. Is measurements automatically tagged with universally recognized metadata? The metadata enables automatic data discovery from the cloud, and The metadata information has the calibration constants, the standards, instrument used, quality indicator. You know, is this really good data? Is this kind of medium data? Is this poor quality data? And it facilitates appropriate use by third parties, okay? So that someone who didn't create the data can use the data. And I think this is the most important thing. If we don't do the first two, we got to do this. And then, finally, if you've got the data up there in the cloud, now imagine a library of ocean apps. The ocean apps might be, let's imagine an app to upload citizen data. So you have an app on your phone that if a citizen is out there making some observations, maybe just pictures underwater from a scuba diver that shows the health of a coral reef, can upload that. Or apps that enable data discovery, or to ensure maritime safety, tsunami alert. You know, you're on the beach in Indonesia and you get an alert that a tsunami's coming. Or to encourage maritime conservation. A good example of that is we already have the Seafood Watch one, but you can imagine all sorts of other flavors of apps that encourage marine conservation. Maybe there would be ones that show you which products you should use that are certified as being safe for the marine environment. Or to promote ocean health, like a HAB watch that tells you when it's safe to go to the beach or not. So a whole library of apps, but no one's going to develop an app if there isn't data in the cloud that the app can work from. And there's not going to be data in the cloud if there's not metadata that it's tagged with. Okay, so what's holding this all up? For this vision to happen, we need standards, all right? So none of this is going to happen without standards. So for standards to happen, we really need, as a community, to come together and agree that we're going to develop standards. Standards for instruments, standards for data, standards, and for standards to happen, we need to act like a community. So, back in the days of challengers, you know, there wasn't really much of a community. You know, there was the little scientist working in typically his lab. And then we evolved to institutions. And if you look around, there were typically institutional standards where institutions developed their own classes of ROVs or their classes of AUVs, or you know, they tended to be even their ships tended to have ways that they operated, but they didn't tend to interoperate between institutions. So now we need to look at, can we rise up above this and come up with national standards or even global standards to enable this vision to happen? So I started looking at what communities do have standards. And one thing that seems to be a driver is, what does the funding landscape look like? Okay, so in our case, the funding landscape, right now we have, well, we had in the recent past that was largely driven by NSF, NOAA, and ONR. Now we're adding substantial input from private funding sources, Packard, Moore, Schmidt, and in the future, we might even have more diverse funding sources than that. If I look at communities that are really good at setting standards and setting priorities, they tend to be communities like, say, the astrophysicists that have one funding source and one sort of homogeneous way that they interact. A diverse funding landscape can often work against a community's ability to set standards. And so the question is, as our funding landscape becomes more and more diverse, how do we come together more tightly as a community to set standards and work together? So our challenge is going to be to unite a global community with diverse funding sources to set priorities and standards, to ensure that appropriate stakeholders are at the table in such discussions, and not preclude the emergence of a disruptive technology in such discussions. Because what can happen is if one gets too rigid in such discussions, then one precludes the disruptive technology from coming in that can actually be the important new breakthrough that actually goes back to those goals that I originally laid out in the very beginning. So, in terms of meeting this challenge, I would like to propose to all of you that we come together as a community and discuss what is the appropriate role of the funders that I told you about. The funders being the federal agencies, the private funders, probably the crowd is not going to be at the table, but basically the main funders. Institutional consortia. We have groups like the Consortium for Ocean Leadership, which I think could be an effective convening body for some discussions. Industry has to be at the table because there's probably not going to be a robust and productive discussion if we don't have industry participating in discussions of standards. Professional societies could be helpful in some of this. We've got appointed commissions that also could be helpful, such as the Joint Ocean Commission. Reports from scholarly councils, for example, NRC sometimes can be helpful by, if the funding agencies, for example, commission the NRC to do a study on standards, that could be helpful in sorting through what some of the groundwork that may have been done and making some recommendations. And then, of course, we've also seen sometimes in the past where community workshops, those have been very helpful for things like the ocean drilling program in getting the international community engaged in some discussions. So before I open this up for discussion, let me just leave you with my vision of where we might be in 9 years' time if actually all of this came about, that we had data in the cloud that was metadata tagged, and it led to a number of apps that people had on their cell phones. We had an ocean-aware public that trusted the data, trusted the apps. We had a plethora of vehicles that had interoperable instruments out there, and just one example of how that could actually change the face of the way the public is interacting with the oceans. So imagine the year 2022, the sesquicentennial of Challenger. Every citizen in Florida has a phone app that predicts ranges of coastal flooding based on tide information, storm surge, IPCC projections of sea level rise, meteorological-driven current variability, and LIDAR-based coastal elevation. No one is ever foolish enough to purchase a home, begin a major project, or even go to the beach without consulting the app. Citizens are empowered. Okay, thank you very much, and I'm happy to take questions. Yes, Henrik.
You raised some really important points, and that was a great speech. To me, the biggest challenge we're facing as a community, and not only this community, but science in general, this cynicism towards science, and how do we, the real problem, as I see it, is to reach the 40%, I don't know how many it is, that get all their opinions from Fox News. Because as long as we don't get them on board, you know, we're preaching to you're preaching to the choir in this room, and it's something we see. I was at an event up at Harvard University talking about climate change a few weeks ago, and everybody in the room agreed. But those people showing up for that event were not among those 40%.
Yeah, Henrik. Let me contrast climate and weather. Okay, we have no problem in this country with weather. You know, everyone is kind of on the same page with weather. And everyone basically has access to weather information. Weather is a good example of a field where there is broad access to data that has standards and that everyone has apps. I have probably 4 apps on my phone that show me the Doppler radar coming in and that give me temperature and whatever. Everyone can verify weather for themselves. There's never a question about it. And so what I'm thinking is that we need to get every single piece of science, and weather is basically science, you know, weather science. We need to get every single area of science, piece by piece, onto the same footing that weather is, so that every citizen has access to the data and can verify it for themselves. And the thing about weather is that there is, the interpretation in it is in the predictions, okay? And the, there's, so that when people say, well, but weather isn't controversial, well, there have been times when weather's been very controversial. But basically, it doesn't seem as controversial today because people have worked it out because they all had access to the same observations. And that's what we have to do with every piece of data, is give everyone access to the same observations, have it the same quality monikers on all of it, and let this work itself out the same way we did with weather.
Marcia? Over here.
Okay, yes. Whoever has the mic has the floor.
Chris Sabine from PMEL. Thank you for a very wonderful and inspiring talk. I think it was a great kickoff for the workshop, and I really enjoyed it. But I got the sense from this talk, and even in your answer that you just provided, that you feel that if you just make the data available, that the people will use them. And it's been my observation that people in general, at least in the United States and other places, have a real disconnect with the oceans. They see that the oceans are irrelevant to their lives. And in this period when people have shorter and shorter attention spans, you mentioned the defunding of education, but I wonder, I didn't really see a piece in there about figuring out how to really engage the public and the people that are not directly involved in the research. And I just am worried that you put the data out there and it's just going to sit there.
Okay. Well, first of all, in my previous answer, I don't think the working out is going to be done by the people. I think that's going to be done by different scientific groups and climate skeptics and everyone else. I mean, there's going to be a lot of people who are going to have to work out based on all the data being universally, there being a common database that everyone works off of. I don't think your neighbor next door is going to be doing climate projections. So that's not what I meant by that. I do think that perhaps you're underestimating the interest that people will have in ocean information. And let me just give you a few examples. When I was director of the USGS, USGS started making available water information just on stream flows that had been water that was used, or information that was used mainly for scientific purposes. And it was amazing how many people started downloading that water information and the variety of uses it was put for people who were using it for farmers who were using it, kayakers who were using it, people who were using it for, everything from recreation to people who were water managers to sewage treatment plants to everything. I mean, it was uses that we never even imagined when we put it out there, and people writing apps for it that were specific apps for specific uses that we never even imagined until we put all that data out there on the cloud. And I think you'd find that for ocean information as well.
We have time for only 2 more questions, and the lady has the mic, and the other questions are going to come from the web. So if you have questions that haven't been answered, just go sign on to the website, and then questions will be, we'll come in and we'll log it, and then we'll try to respond to you. Please go ahead.
Thank you for an excellent lecture. I wanted to expand on the last point and ask you a very specific targeted question. From when I view the United States, taking a US-centric view of the public awareness of the oceans and stuff, I see that essentially we have a donut. Right, the people on the center on the ring of the donut have some interest, at least, because they live in a coastal area, like your Floridians that might download an app and monitor, coastal environmental processes or whatever, and add that to our database. But what are we going to do about the center of our country, right, the middle of the donut hole, which is where I am from, and somehow I fell into the oceans. But I really have a strong concern about the center of our donut.
Yeah, that's a good question. And I think one thing that would be good to do is that as we develop projections that say help the ranchers and farmers in Kansas understand things like their future climate projections, help them understand how much ocean information is actually being assimilated into those projections so that they can see that ocean information is actually essential to their future, so that they feel that it is actually important to them as well.
Thank you so much, Marcia. We have one more question from the web audience. Jeff, would you like to read it?
Sure. So this question comes from Mike McCann at Mbari. What specific things can funding agencies do to improve the data interoperability problem?
Well, obviously there's a lot that funding agencies can do. I think if I think there is a leadership issue here, and it would be wonderful if funding agencies supported a proposal to get some roundtable going with funding agencies, industry, and private funders to solve this data interoperability problem once and for all, because I really think that's going to be, as I said, I think it's the most important of all these interoperability issues is the data interoperability. If we could make that happen, I think a lot would take off.